We've all heard it. Why didn't we check that before we ordered 5,000 of them? Really, I didn't think the extra load would make that much difference. So we didn't actually check to see if plastic would hold up, I guess? We don't really check for buckling. And you say the same weld broke in every prototype. That explains the shaking that our customer was complaining about. So then how many cycles did it take before it flew apart? Hey, why didn't we check clearances at the expected running temperature? And more often than not, these design flaws occurred early in the project when key design decisions were being made, but they didn't manifest themselves until much later during FEA or prototyping. Too often is the feeling that these things just happen. Sales said we had no choice. We had to meet the customer deadlines. We never control the schedule. That's up to management. Well, we got away with taking shortcuts the last time with the design process. And often, you don't worry too much because you know you'll be doing testing and prototyping at a later stage. We've all been there. You've been through the conceptual design, you've finalized the detailed design, and you've created all the required design drawings. And while this is going on, and to keep the project on schedule, you've pre-ordered various parts and provided specs to marketing. Plus, sales has made some commitments, and they've put some pre-orders in place. And then you do system FEA or prototyping, and you discover a design flaw. The team does some hasty redesign, maybe accepting some performance limitations, maybe some compromise on the appearance, or the product release is a little delayed, which means a few lost customers. And of course, extra time means spending extra cash, and you'll need to get to work on a new version sooner than you'd planned. The bottom line is that the design's value is diminished. But these things happen, right? Wrong. It doesn't need to be this way. Let's look at the typical product design process. Your specific tasks may vary, but most product designs generally include conceptual design, detailed design, creation of the detailed design drawings, system FEA, prototyping, and testing. And in most organizations, these stages overlap. To get a product out sooner, for example, to meet customer agreements, or to meet externally imposed shipping times, such as an annual release schedule. These task overlaps are possible because organizations assume that the initial design is right, and that it's okay to make decisions and investments based on that initial design. But what if that assumption is wrong? What if you find during validation that a part should have been made of stainless instead of plastic? What if you discover you need a casting instead of using sheet metal? What if the plan failed to consider the allocation of space for drive system controls? Here's a trend line that represents the cost of making major design changes at different points in the project. Catch the problem early, and the cost is low. But later in the design, major changes are frankly unaffordable. Making matters worse, design changes can cascade. Manufacturing plans may need to be updated or even scrapped. Because the entire project was initiated based on the assumption that the initial design was okay. Now here's a second trend line that shows the odds of optimizing your design. Early on, it's really practical to optimize things, to reduce product or manufacturing costs, improve quality, or accelerate the time to market. But once you're into the validation, optimization really goes out the window, and you live with what you have, and it's unlikely you'll consider any changes that will further optimize the design. You can think of the place where these two curves cross as the point of no return. At this stage, product teams shift from creation and innovation to focusing on getting the design to work and getting it out the door. The point of no return is generally not a scheduled event, but many designers think of this point as the transition from the design phase of the project to the validation phase, because this is the point where engineers need to make what they have work. And here's one more trend line. This indicates how much the design team really understands their design's performance over the course of the project. At the start, you don't know much. And once you're through prototype and testing, you know a lot. This is especially true for new projects and design updates where you're exceeding the original specs. Of course, once you're into system FEA, prototyping and testing, you're learning quickly. But by now, you're past the point of no return, and it's too late to make major changes. You can think of the gap between the cost of making design changes and what you know as the risk to the project. And in many projects, the risk is high because you just don't know enough early enough. But what if there was a way to increase knowledge and insight of a product's performance earlier in the design process? You'd have more opportunity to optimize the design and improve your chances of finding critical problems when you can afford to make changes. And most important, the more you know up front, the more you reduce project risks. Let's now step back and look at total value over a product's life cycle. When a project is started, the value is negative because you're in the investment phase. But once you begin shipments, value grows and becomes positive. And eventually the product matures and the value ultimately stagnates. And you have to invest money to make money. An investment is all required before the company can realize a return. The design process we've been talking about only represents a very small part of a product's overall life cycle. Yet the upfront decisions made in the design process dictate how the rest of the product life cycle performs. In simple terms, better upfront design decisions let you spend less on development and manufacturing and ship the product sooner. The result, lower costs and higher revenue. And a better product with higher quality and reliability means the product will be more competitive. It will sell more units, and you'll have the potential to extend lifetime revenues. So let's summarize. With respect to the product design life cycle, if you could increase knowledge early in the design process, you'll have a chance to optimize the design, and you reduce the risk of finding issues during FEA, prototyping, and testing. And by making better design decisions in a timely fashion early in the investment life cycle, you can lower overall investment, derive higher revenues, and extend the product's overall market life. If you've listened to this point, you must be interested. So my question for you is, what are your next steps? First, it's important to state that the status quo is not good enough. You need to take action. If you're using Autodesk Inventor, ask yourself, are you creating projects that use any material other than steel, that require welds or bolts, that involve shaking or dropping, that experience temperature changes, that include parts that slide or rotate or bump or spin, or that have parts that will potentially buckle? If the answer is yes to any of these questions, then take a close look at Autodesk's Nastran in CAD product, providing real-world simulation to understand your design early, before you reach the point of no return. And then, to learn more, please contact your Autodesk reseller, or else click on the button shown here for more information.